Hi guys, this is just a brief video introduction to Lab 2B, specifically kind of the things that were discussed in the pre-lab and the handout. So to start out with, let's review what we talked about last week for Lab 2A's pre-lab, because this will be pretty important moving forward for this lab. So last week we designed a non-inverting amplifier, and the goal for that amplifier was for the gain to be 11. So we talked briefly about the fact that there are many different kind of recipes for op-amp circuits. One of them is for the non-inverting amplifier, and it's the diagram shown here. So there's a resistor going from the negative terminal of the op-amp to the output terminal, as well as a resistor going from the negative terminal to ground, some voltage input at the positive terminal, and then some load resistor at the output. So last time we had to figure out what values to choose for R1 and R2, and this was to get the gain of 11 that we wanted. So let's kind of review how we found those values so we can move forward with this lab. So from last time, we started by looking at the KCL analysis at the circled node. So one little fact you guys had to trust me on was that the input current into the negative terminal was 0. So one way to think about KCL is by thinking about the idea that any current flowing into a node has to be the same thing as the current flowing out of the node. So looking at the node that I've circled, what's the current flowing into that node? So the only current flowing into that node is I2. Now this has to equal the current flowing out of the node, and the only current that's leaving that node is I1. So now the key is to relate I1 and I2 to the different voltages that we have in the circuit. And the point of this is that we're trying to find the gain of the circuit. And the gain of the circuit is the voltage at the output divided by the voltage at the input. Remember that this has no units to it. Or if you want to think about it, you could think about it as volts over volts. So let's start by looking at I2. How can we relate I2 to the voltages present in the circuit? One way to think about this would be to think about I2 as the voltage drop across R2 divided by R2, and this is just from Ohm's law. So let's figure out what that voltage drop is across R2. So if we look at R2, we can see on the right that the voltage there is V out. And on the left, it's the voltage at the negative terminal of the op-amp. So another thing you guys had to kind of trust me on last week was that for op-amps, the positive voltage terminal and the negative voltage terminal are approximately equal to each other. With this being the case, we know that the voltage at the negative terminal is equal to V in. So in other words, the voltage drop across R2 is just V out minus V in. So then I2 would just be V out minus V in over R2 by Ohm's law. The other current we need to figure out is I1. So I1 again, similar to I2, could just be thought of as the voltage drop across a resistor divided by the resistance. So this time we're looking at the voltage at the negative terminal, which we determined was V in, minus 0 volts, the ground. So the voltage drop across R1 is just V in. So then I1 is just equal to V in over R1. Now, using some algebra, we can rearrange things. I just pushed the R2 up from the denominator on the left to the right. The same thing with R1, I just pushed that up as well. So we have R1 V out minus R1 V in equals R2 V in. I just rearrange things to get V in on one side and V out on the other. And then you can end up finding the ratio for the gain, which is just V out over V in, which is equal to R1 plus R2 over R1. Remember again that this is unitless for this amplifier because we're taking an input voltage and getting an output voltage, so the gain is unitless. So we wanted the gain of the amplifier to be 11. So using the rearranged equation, we can determine that the ratio between R2 and R1 should be 10. So we decided to choose that R1 would be equal to 1 kilo ohm. So with that assumption, we could then assign R2 to be 10 kilo ohms. So the difference this week is that now we're dealing with a stereo amplifier. So a stereo amplifier has to deal with two channels of audio, the left channel and the right channel. But the neat thing about this, and what makes it a little less complicated than you guys are probably thinking, is that those two channels can be amplified separately. So what does this mean for us in terms of our lab? This means that basically we just kind of have to double what we're doing. But before we get into that, we're first going to just add an extra capacitor and resistor to kind of like input of the circuit, just to keep everybody safe and happy. Don't worry about the details for this now. Later on in the class, we'll learn more about capacitors and this combination of capacitor and resistor. But for now, it's another one of those just trust me moments. Just put that in your circuit. It's a 0.1 microfarad capacitor. I'll point them out to you in the lab, and a 100 kilo ohm resistor just to ground. Alright, so remember I said that the stereo audio has a left input and a right input. So basically, the circuit you're going to build this week is going to take an audio input, the two channels of that, in two separate paths, and just have two different amplifiers on your circuit. And at the end, you're just going to take the output of the left channel and the output of the right channel and put that into the audio output for the circuit to the speaker. So one thing you guys will be doing differently in today's lab is that you'll actually be soldering. So instead of using your breadboards and the cadet boards that you've used in previous labs, you'll be using little green circuit boards. Remember that each of you guys should have your own green circuit board at this point, so you can build your own individual amplifiers as kind of a take-home for the class. So our goal for today is for you guys to hopefully be able to solder and put together one of the amplifiers. So for instance, the left channel's amplifier or the right channel's amplifier, either or is fine. So here's an example of what your board might look like after today's lab. So another thing to notice is that the board's a little different than the breadboards that we're used to using. So on the breadboards, we had nice little rows and columns throughout the board that would be shorted together for us, and it was pretty convenient for connecting things in series and parallel. This time, you have to take care of the connections for yourself. There's a few places on the board, near the screw holes or on the perimeter of the board, that do have a few of the metal pads shorted together, but in general, all the metal pads are separate. And remember that you can always test your connections using the ohm meter, and there's even a cute little continuity setting where it'll beep when things are connected. So just keep this in mind as you're soldering things so you can test to make sure that your solder connections are good and that things aren't soldered together that shouldn't be. The other thing to notice is that the solder pads or the metal pads on the board are only on one side of the board. So when you're soldering, make sure that the soldering is happening on the side of the board where the metal pad is located. Don't try to solder to the plastic on the back of the board. This will just melt the board and kind of smell funny and not really work too well. So just keep that in mind while you're working on things. So the first part of the lab today, you're just going to place down the audio jacks and then a nice little chip holder for the op amp. So this way we don't have to solder in the op amp and take it out again if something happens to the op amp. You can just push the op amp into that little chip holder and pull it back out as many times as you need to, which is hopefully not too many times, but we do it just to be safe. So you'll want to place the audio jacks closest to the edge of the board as possible. This way you can plug in the audio plug, the auxiliary cable, without having to bump into the board too much. So just try to keep those as far out to the edge of the board as possible. I chose to put mine near the screw hole locations on the board just for convenience. But you can really put them anywhere. Just make sure that you plan out your board before you start soldering so you don't have to remove things later.